In this video, I will explain how to solve complex equations through 3 examples. First problem. Let's start with the first problem. Essentially, this question requires us to transform a complex multiplication and addition equation into a simpler form. To simplify multiplication, we should consider using this formula. Looking at the numbers in this equation, we notice something special. One number is equal to 100 plus 1, while the other is equal to 100 minus 1. This allows us to apply the formula. To simplify the multiplication process, the multiplication step now becomes straightforward. Next, we simplify the addition and subtraction. First, we rearrange the numbers. We then observe that the ones and tens digits of the two numbers are identical, and they form a subtraction relationship. This means we can use the formula again to simplify the subtraction. Finally, for the remaining addition step, we see that the sum of the numbers in this part equals 200. Given that the number to be subtracted is 20,000, we only need to focus on the ones digits, making it easy to determine the final answer. The key to solving this type of problem is to recognize number pairs that add up to tens or hundreds. These pairs often provide crucial clues for simplifying calculations. Now, let's move on to the second problem. The conventional method for solving this problem is straightforward, but involves too many steps, requiring 3 additions involving integers and fractions, as well as 2 divisions with fractions. However, we can streamline the process using a more creative approach. First, we treat this part as a fraction, identifying the numerator and denominator. By multiplying both by 3, we can simplify it to this result. Next, we apply the same method to another fraction. Multiplying both the numerator and denominator by 10 to obtain the desired result. Finally, we combine the integer and fraction to arrive at the final answer. Once again, the key to solving this type of problem is minimizing the number of calculation steps. The most effective way to achieve this is by multiplying or dividing both the numerator and denominator by the same number. By the way, when writing your solution during an exam, Format it this way efficiently to save time. I've written it that way here to make the explanation clearer for you. Third problem. Finally, let's examine the third problem. For this type of equation, the typical strategy is to express both the numerator and denominator in a form that allows for simplification. The key to reducing the fraction is identifying the common factor shared by the numerator and denominator. However, in this case, the common factor is not a single number, but an entire equation. Focusing on the given numbers, we notice that the number sequences in both the numerator and denominator share common elements, the colorful numbers. This means the crucial part of the problem lies in the differing numbers. To handle these numbers effectively, we examine their patterns and characteristics. Looking at the 5 numbers in the numerator, we see that each is obtained by adding 7 to the previous number. The same pattern appears in the denominator. This allows us to rewrite both the numerator and denominator in a simplified form. Notably, the expressions inside the parentheses in both the numerator and denominator are identical, making it easy to derive the final answer. Once again, the key to solving this type of problem is identifying patterns and characteristics in number sequences. These patterns provide essential clues that guide you toward the solution.